example and practical example, and very common to what you're going to be seeing, is a mass on an inclined plane. Now, I've left out some details because we're going to add them in, but often they give you a little bit more by way of detail. I wanted to introduce those as we went. So we've got a 5 kilogram mass is on a smooth plane inclined at 30 degrees. What's the importance of the word smooth?
No friction.
No friction. Now in extension 2, we're going to stop having smooth planes and we're going to introduce friction as a way of increasing the complexity of these type of questions. But in extension 1, it will usually be a smooth plane. It's inclined at 30 degrees and we can see our 30 degrees here. To stop it sliding, it is attached to a light rope, so the rope has no mass. Now, the rope is going to be like this, and it's going to be attached to something else. We can't see that end of the diagram. We need to calculate the tension and normal forces on the mass. So the reason I hadn't drawn the rope in first is I don't actually want a rope there. What do I want acting along the rope? I want a tension force that's going to be along my rope. I have another force, 2 other forces, acting on this box mass. Can anyone think of one of those? One of them's named here and the other one is assumed. Gravity. My box has a mass, so therefore it has a force that is mass times gravity. And we actually extend our tension force so that they're all acting at some point. In reality, for those of you who are physics and like it, that point is called a centroid. It's the center of mass of any object. And we can reduce any object to being one point. It's why basketballers can hold a ball on one finger, reduce it to 1 point. There's one more force acting on this.
Normal?
It's called a normal force. It's normal in the same way that we use the word normal to a tangent. It means it's at 90 degrees. Now for this one, it's at 90 degrees to my tension force, but more importantly, it's at 90 degrees to my slope. And if I didn't have a normal force up here, my mass would come crashing through my slope because nothing would be resisting this, or very little would be resisting my mass. So it's acting back up to hold it onto the surface. Most importantly, there's a 90-degree angle here. So they're my 2 directions. Now, I promised that we would do this 2 ways and that I wasn't necessarily going to show you both. I'm going to try and show you both, even if I don't talk you through them. The traditional method, which is where we're going to start, is going to be resolving all our forces into an XY plane or an IJ plane because we're talking about vectors. We good with that? So if I take my start of a force diagram here and resolve it into the components, and I'll try and get all of our colours the correct way. We start with our mg straight down. It's already in an XY plane. Good to go. Next, I'm going to take my tension force and I want to resolve it into a component this way and a component this way. On our original graph, I'm just going to pull it out here. There's my tension force and I'm resolving it into a component this way and a component this way. I need an angle. What's the angle that I need for this tension force? 30 degrees. Can you see that this little triangle here is on the same inclination as this plane? So this is 30 degrees. That means when I resolve it into my components over here, what's my horizontal component? T sine? Cos? And And my vertical component, t sine. And we could work out what sine and cos 30 are, but that's not our goal at the moment. The normal force is a little bit trickier. It's going to have a component in this direction and a component in this direction. But let's come back over here and have a look at what those forces are. Here's my normal force. Here's my component this direction, which is how I knew it was this way, and my component in this direction. But this is not 30 degrees. So let's have a look. This angle here is 30 degrees. Do you agree? This is what? 90 degrees. So this one is 60 degrees. It's often very, very hard to see, and people make up rules of saying, oh, it's this bit and this bit. Just have a quick look. You guys know how to add up to 180. Agreed? So this angle here is 60 degrees. If you wanted it all to be in 30s, you'd go from this angle and you just change your way around. Normal. What's our x component of the normal force? N cos 60, and our vertical, N sine 60. Again, we could change them to coses if we want to. In fact, when you actually see the nice, beautiful question that I have, it says, show that, and it's all in coses. And you're like, okay, but I'm not interested in that bit. So we now get to here, and I'm asked to calculate the tension and normal forces, i.e. find me T and find me N. How many unknowns? 2. How many equations do I need? How many directions am I in? This is not a coincidence. Let's have a look. In our horizontal direction, the sum of my forces is 0. Who wants to give me a go at writing out what my next line would be? Horizontal forces. I love your MG, but let's go horizontal first. N cos 60 must equal T cos 30. Ooh, wrote it the wrong way round. I could write that as a this one minus that one. I'm not that interested. Later on we might need to be, but only really in extension 2. My next direction, and Gad, I think you had this one sewn up. In the vertical, go for it.
mg is equal to n sine 60 plus t sine 30.
Now, I don't have an n sine 60 up here, and I don't have a t sine 30 up there. What am I going to do to allow myself to solve this simultaneously? I now have 2 equations. I actually know what mg is. What is it? 5 kilo mass. Good. So I actually have n sine 60 plus t sine 30, both of which I know, sine 60 and sine 30, equals 50. Agreed? I'm going to call that equation 1. I'm not going to use this as equation 2, because there's no causes. Do you agree? What am I going to do? How can I resolve this? Change the subject. Which one would you like to change it to? T sine 30? How would I change it to T sine 30? How, T sine 60? How would that help me? I could sub it in where? I like you thinking, if it was T sine 30, I'm like, yes, but it's not. I like your change the subject. Anybody else suggest what I want to change to? change to t. Now, can you guys find out what's cos 60? What is it? Half. And what's cos 30? Root 3 on 2. So what's a half divided by root 3 on 2? Let me write it up. We'll do this first. What is it? 1 on root 3? Yep. We happy with that? This is a great equation too. By the way, I could also change these ones if I wanted to. If I wanted to change these ones, what's sine 60? Root 3 on 2, sine 30, half. So I could change them if I want. I like to leave them until we're all into one row, which I can do. Yes?
Isn't it root 3?
Cos 60, just root 3 or root 1 on root 3? I'm relying on you guys. You think you're confident?
Yeah.
Check. We've got division. What's cos 60? Half divided by? Nice. 1 on root 3? But I'm really happy. I'm with Ariana. Thank you for checking. Because it's nice to know you're playing along at home. All right. So we've got this one. We're going to sub it in here. And in the same step, I'm going to convert all of these. Are we okay with that? You're okay with me doing two things? I don't normally like it, but let's have a go. So, n sine 60. What's sine 60? On 2n. Plus, I'm changing t for this. 1 over root 3n. I should actually tell you what I did, but I'll do that in a second. What's sine 30? And that equals 50. And I am subbing 2 into 1. Just so you know. This is looking good. Do you agree? So now when we do it, we get root 3 on 2. I'm like, this is a bit too large. Plus root 3 over 6. And we get 50. There we go. 25 root 3, that looks better. And then popping it down here. There we go. I like the fact that we got the very easy part wrong. Well done. We happy with that? I'm going to leave it there for a second. You will get a copy of this, but if you do want to take a photo, go for it. We're then going to go into method 2. So,
Because we've got a normal force,
yes.
and our unit for forces happens to be abbreviated with a capital N.
Do you think we should write it better?
What would you suggest as an alternative?
Newton.
Yeah.
The only other thing I could think, so Mr. Wu quite rightfully is going N and N. Ooh, this is not great. So you could either expand it to be newtons, or you could write
Fn.
yes. So you could either do this, or, and the whole way through you could write force N if you wanted to. And then this one would be force T with subscripts. There probably should be some clarification there.